to our 2022 inaugural Energy and Espresso sessions. In these sessions, we try to build and connect with one another and really present on a specific knowledge area. It ties right into a safety moment that I want to present and kick us off with. Knowledge sharing across industries is incredibly important for process safety. It's something we don't want to compete on. Everyone wins when process safety is done well. And oftentimes we're learning from other industries. The hardest part is how do you connect to the other industry and how do you get to know what someone else does? And in effect, that is the point of what we're trying to do today. So I'd like to kick us off with a talk on nuclear energy, and I'll turn this over to Matt Maringer, who is our guest, and to introduce himself before we go over some ground rules. So Matthew, the floor is yours.
Yeah, so Matthew Meyer here. I am just located east of Toronto in Ontario, Canada. I work for Ontario Power Generation and specifically in the nuclear energy division. So I'm a nuclear engineering by background. I also have my graduate diploma in nuclear technology. I'm a professional engineer and also a project management professional. And on the side for nonprofits, I'm a board member with the Canadian Nuclear Association and also the Canadian Operating Officer of North American Young Generation in Nuclear, which really tries to build the professional network in the nuclear industry for young professionals. So professional development, networking, public information, and community outreach. So happy to be here and maybe won't be able to answer all the questions, but I will try my best based on my 8 years in the industry and my background.
Great. Thanks for a wonderful introduction. Some just ground rules. Again, we're recording this session for posterity. We want this session to be interactive. Put questions in the chat. Feel free to raise your hand. We've enabled mics on, off, and cameras to go. Matt and I had discussed on how we want this format. If you have something, we'll try and address you when we got a right moment. And there will also be a 5 minutes at the end. Our agenda today, for those of you who love this structure, kind of a structural focused mind, is we're going to quickly do a high-level overview of the industry. We're going to talk about Matt's career entry into nuclear energy, and then really get into that meat of what's new and exciting in the industry. What should we be looking for? So maybe to kick us off, in a minute or so, what can you tell me about your industry?
Yeah, so I think the nuclear industry is one of the most misrepresented industries out there, especially for climate change. For perspective, it's around 10% of the world's power. In Canada, it's around 16%. And in Ontario, it's 60% of the power. It's zero greenhouse gas emissions. And, we're going to talk about radiation, spent nuclear fuel. These are topics that everyone likes to talk about. But if we're talking about reaching net zero, the IEA says that we need to double or at least triple the share of nuclear energy around the world to meet those targets. So nuclear with renewables, with energy efficiency is one of the main ways that we're going to get there. And especially with the new developments in nuclear for transportation, for desalinization, for small modular reactors, for fusion, these are some of the really exciting topics that I want to get into. I think when people think about nuclear, sometimes they think about the old legacy reactors, they talk about Chernobyl, they talk about the beginnings of our industry, and they really don't know what's happening with the small modular reactors, with the novel technologies, how much safer and how much good we're doing for the world. So really happy to talk about that. And again, really want people to ask questions. I know a lot of people maybe don't know a nuclear engineer. If you're in Alberta or different other places that you don't have nuclear in your backyard, you may not be as familiar with it. So really that's why I'm here to share my perspective. Ontario is a nuclear powerhouse. Right around Toronto, we have 18 different reactors of the 19 in Canada. So it's right now heavily in Ontario, but we're hoping to expand outside of that.
Well, that's great. Just maybe one more question around that area is who are the major players? Who are the big names? Who are the industry quote unquote leaders?
Yeah, so there's 3 utilities that operate nuclear power. So Ontario Power Generation is in Ontario. They operate 10 of the reactors here in Ontario. They also operate hydro, gas. They used to have coal. They have some solar installations, but in Ontario, they're the major focus. We are quasi-provincially owned. And we're also looking at small modular reactors that are going to go out to Alberta, Saskatchewan. The private industry for nuclear is Bruce Power in Ontario. They operate 8 units, and they are leasing the reactors from Ontario Power Generation. Out east in New Brunswick, they have 1 reactor, so that's New Brunswick Power. And then there's a whole plethora of suppliers out there, ES Fox, BWXT, SNC Lavalin, Cameco, Laker. There's all these suppliers that go in there, and we work under the Canadian Nuclear Regulatory Commission, the CNSC.
Wow. So in your terms, like how did you get into this? Did you just fall into nuclear engineering?
Yeah, so I was really interested in engineering. I really like math and science. I was torn between civil engineering, aerospace, and nuclear. At the time, I was applying in 2008, 2009. NASA started to have a slowdown, so I switched from aerospace. And then I really started to look at energy, how energy helps humanity, how the need for electricity was going up as we started to electrify the sector. So I really thought energy and electricity in particular would be a good thing, especially with climate change. I really wanted to get into something that would make a difference. And the more I started researching into nuclear, the more I realized all the benefits it produces and how much of a misrepresented industry it was. So I wanted to learn more. So I went to Ontario Tech University, which has the only nuclear engineering program in Canada from the get-go. So for others, you usually have to specialize in 3rd year. So you go to something like engineering physics or engineering science. And then 3rd year, you specialize, where this university, right from the get-go, everyone in your class is studying nuclear engineering. They have nuclear labs, all the professors are there, and it's located right near Ontario Power Generation, which actually has nuclear reactors. So I just thought that was something really interesting. And yeah, every day I'm learning something new.
Well, that's great. Can you tell me a little bit what you currently do at OPG and also in across an industry?
Yeah, so I've held a variety of roles. So OPG has 10,000 employees. And like I said, we're across various sectors. So when I started as an engineering intern. I was a cost and schedule analyst. So what that's looking at is building the schedules, looking at the cost for major projects. So that was my first experience for 14 months. I got hired as a new grad right out of university. So with that, it's a developmental program. So you do 4 months in one station, 4 months in another, and then you go to your home base. So I did 4 months in reactor safety. So again, just looking at a lot of number crunching. If this valve or this system goes offline, what's the safety impact? Looking at the numbers and probabilistic safety. I was then a modification team lead. So again, project management, putting together projects, did that for 4 months. And then I was looking at performance engineering. So I was looking at environmental qualification. So it's really about the safety impacts of non-metallics. So if we have a radiation release or a chemical release, will a gasket survive? Will the system be able to perform its safety function? I was in stakeholder relations for a bit, and now I'm actually a business analyst in nuclear waste. So looking at the different type of opportunities or projects that we can take the waste and turn it into commercial viability products or reduce our impact on the environment.
Wow. What's the most interesting project you've worked on then, I guess, across that spectrum?
There's a lot. I think nuclear waste has a lot going on right now. So looking at like sucking carbon-14 out of some of our resins, where we could sell that to industry partners. For example, in the water that we use in the reactor, as it becomes radioactive, it becomes tritium. So we actually pull that tritium out of the water, continuously reuse it, and then we immobilize that tritium and sell it as helium-3. So there's a lot of projects looking at innovative ways to take our traditional waste and either have a benefit from that, whether that's medical isotopes or just reducing our impact from those.
Wow. Okay, so that's something I definitely didn't know about. We didn't prep for this, but I'm going to go right into it because I really wanted to understand more about this piece on the extracting these new items. When I think of a nuclear plant, I only think of the splitting the atom and then containing all the energy from there. So are these new processes you guys are building? Is that like an engineering opportunity to like build a new plant beside the nuclear plant? Is this a common practice?
So it all depends. Like I said, for the resins, so resin beads, basically, it's just a chemical exchange process. And when the resin is left over, sometimes it has radioactive particles in it. So you can use different technologies, you can use different processes that would basically take out selective ions. So for this, it'd be carbon-14. Carbon-14 is the highest amount of radiation in those. So they can selectively remove that. And again, these processes, it could be like a skid that moves around like basically like a semi-truck trailer. And yeah, through that process, they can immobilize that carbon-14, which can be used for carbon dating, other type of sources in the industry. And then you're taking that resin, which now doesn't have radiation, and you can recycle it traditionally, and you don't have to do any special techniques for that. So again, some of it, like removing the tritium from the water, we build that directly into our station where we have that as a permanent structure. Some other type of technologies or services, we either partner with a vendor or they have a new engineering solution, or it can be something that they bring in like a skid. So it all depends, but yeah, these are some of the innovative features that we're working on right now.
There's a couple questions in the chat. I think we should address them. May, do you want to come off mute and come on camera and join the conversation? What's your question?
Yeah, thank you so much for the initial questions. They were all very interesting. So I put two questions in the chat. So I start with the first one and then give the virtual mic to Brody to ask their questions. My first question is, considering all the costs that goes towards the safety of the process and waste management that you talked about in nuclear sector, how expensive the power produced by nuclear is in comparison with other resources, and just talking about Canadian resources and Canadian power production?
Yeah, so I'll first start with Ontario. So the Ontario Energy Board is who regulates the prices in Ontario, and nuclear is actually the second cheapest form of energy. So hydroelectric is the cheapest, nuclear is the second, followed very closely by gas, and then orders of magnitude higher are actually wind and solar, because we build in the inflation and the global adjustment price. So really what the interesting thing about nuclear is when you're paying for the power, it's already taken into account the decommissioning and the disposal costs. So this is something we don't see from all sectors, is that's just an unforeseen cost that gets added on later. Or for something like intermittent renewables, they're not actually factoring in, okay, when it's not available, now we have to pay something to provide peaking power. Nuclear is a baseload technology, so that's all built into that for that disposal. And yeah, safety is one of the major costs. But again, most nuclear stations we see can pay themselves off in about 10 years. And that's why for OPG, now we're returning to the government billions of dollars every year back to the taxpayers. So it's a high initial investment. And that's one of the biggest things, is if you can partner with the government or having a financing structure for that, then that will recoup your costs much quicker.
Do the costs scale up as the plant goes bigger or smaller, or is it all pretty much like one big chunk is going to be tied to the same thing?
It does depend, yeah. So a lot of it is the regulation. So getting that initial license to operate the facility, that is quite a big chunk of it. And there's a ton of concrete in the reactors itself. So for the containment building, for the subsequent structures. So that's why in nuclear, if you can build a bigger reactor, you do get economies of scale. And that's why for the Canadian technology, what we do for these is we build 4 units or 6 units or 8 units tied in together. So they have one switch yard, they have interconnected safety systems, they have interconnected concrete. So when it's operating, everyone's in one common spot, where around the world, sometimes they build single units or 2 units. And that's where really we see in New Brunswick, they have a single unit that is much more expensive than for Darlington, which has 4 units, because they built the first one, they learned a lot of lessons, and then they had they built a concrete plant right next to the station. That's how much concrete we used. And then we built the second one a little bit cheaper, third one cheaper, fourth one even cheaper. So you get economies of scale really quickly.
Cool. May, did you want to follow up with your second one, and then we'll go to Brody?
Okay, sounds good. So Matt, you mentioned that when you studied nuclear engineering, there weren't that many opportunities to actually study nuclear engineering. So I guess that a lot of people that you work with in different teams that you're involved in different projects do not have background in nuclear engineering. I'm interested to learn what educational background folks have that you currently work with.
Yeah, and so maybe I misrepresented that. There is ways to study nuclear engineering, but as a undergraduate degree from day 1 to year 4, there's only one program, but there's a lot of other programs like U of T, Royal Military College, McMaster. They can take engineering science, engineering physics, and then specialize in nuclear in your 3rd and 4th year. But we have a lot of people that are mechanical engineers, mechatronics, chemical engineers. We have so many trades out here, boiler makers, pipe fitters, electricians. So for example, where I work at like Darlington, we have 2,000 to 3,000 people working on that single site. So we have communications experts, we have legal teams, we have everybody. So that's what I think some people get confused about is you don't have to be a nuclear engineer to work at a nuclear power plant. Like I chose to study it and I have a bigger understanding of some of the systems, how it works together, but we need mechanical engineers, we need design engineers, we need civil engineers. Like we have a lot of concrete, we have a lot of valves, we have a lot of pumps, motors. Like the nuclear station itself is very similar to other type of stations. Like our secondary side is a turbine, we have a generator, we have a switchyard. So a lot of it is commonality. It's just the core itself and how we produce that heat. So how we boil the water is the nuclear specifics, but a lot of it's just general power production.
Great. Brody, do you want to come on camera and off mic and ask your question?
You bet. Thanks, Matthew, for talking to us about this. I was curious on how close or remote can a plant be for it to be effective? You know, you talked a lot about at the beginning on the social license to operate piece that comes with nuclear. Can you have these things out in the boonies, or do they need to be kind of close to where they're providing that baseload power?
Yeah, and this is a great point, and this is where small modular reactors come in. These small modular reactors can be 0.1 megawatts electric to 300 megawatts electric. So they're very scalable and they're much smaller than the traditional reactors we have, which are usually around 600 to 1600 megawatts electric. So these new small modular reactors, they can be built right next to communities because of the inherent safety features. They can't physically melt down. They have passive safety systems. So for example, in Fukushima and Chernobyl, one of the problems was if you lose power, you can't shut down the reactor, you can't keep it cool. These new small modular reactors have natural circulation, they have passive safety features, and actually they have tamper-proof fuel. So the fuel, it's a triso fuel, so you actually can't take the uranium out of the core and extract uranium from it. So this is where they're really looking at having small modular reactors in communities, in mining sites, in these other spots to have it closer to where the power is needed. And again, the farther you have your power source from, you get the I-squared losses for transmission. So that's why it makes sense. In Toronto, we have these big honking units. But if we want to go to Saskatchewan, if we want to go to Alberta, if we want to go to the territories, that's where we're going to have the smaller units that are going to be operated near the communities.
For context, sorry for the follow-up question, but like, what is small? Like, is small the size of a car, size of a house, or size of the giant smokestack like you see in The Simpsons?
Yeah, so when we say small modular reactors, it's anything under 300 megawatts electric. What that actually looks like, most of it is underground. So the surface area would typically be like a house to all the way down to a car. So it's very, very small. And that's where we see the benefit of nuclear. You get 2 million times more energy from the same mass as compared to getting it from conventional energy sources. Because when you're splitting it, you're actually splitting the atom rather than ripping off the electrons. So you get so much more power density from that. And that's why it can be so much smaller in terms of a footprint.
That's great. Good questions, Brody. Hopefully I get this name right. Milika?
Hi, it's Milica Vojacic. I'm actually the coordinator of the Young Energy Professionals program here in Austria, so I'm very happy to be here today. As we all know, one of the biggest challenges, of course, with renewables on our way to net zero is the mismatch between the supply and the demand. And you mentioned this, Matt, at the start, that nuclear power plants would be able to compensate for that. But nuclear power plants have limited capabilities in that sense because the power output can't be adjusted so spontaneously. So keeping this in mind, to what extent is nuclear energy really compatible with renewable energies? And is there some sort of technological progress in this area?
And this is a great point because the traditional reactors, that's how they were built to operate. 100%, we're going to supply it, you're going to take it, that's what we're going to do. And that's really how they were built, that's how they were designed, and that's why they kept getting bigger, because you get economies of scale. With the new grids, and especially with renewables being intermittent, there's now base load that has to load follow. And that's what some of these new SMRs are actually being able to do. They're rapidly able to oscillate power so they can start to follow the load of the grid. And also now what we're looking at is we're looking at a cogeneration facility. So again, what this might look like is you have a small modular reactor, you have wind and solar, and you have a molten salt battery. So what the SMR is doing is it's producing power, but let's say it gets really sunny, it gets really windy. Now it switches, so the wind and the sun are producing energy, and the nuclear switches to desalinization or hydrogen production, or it stores that heat in a molten salt battery. So now, rather than just curtailing the wind or load shedding, now what you have is you have useful energy, which is again doing hydrogen production or desalinization. And this wasn't possible before with nuclear technology because they weren't high enough temperature. But now these new small modular reactors with molten salt reactors, with liquid sodium fast reactors, they operate at a much higher temperature, much lower pressure. So now you can talk about district heating. You can take that waste heat and make it into hydrogen. You can do desalinization. So that's really what they're starting to look at, is with the new grids, they're realizing that you can't just keep pumping out power and hoping the grid will accept it. It has to be able to load follow, or it has to be built in with other type of sources and use that waste heat to keep producing power. Because I know in Austria right now, nuclear isn't allowed, same with Italy. But again, that's why the hope for small modular reactors is a very different technology. And even Denmark is shutting down their nuclear, but they're going to switch to small modular reactors. So I think a lot of the world governments see the potential here.
Follow-up question for me is who's got the most SMRs right now? Who have them in production?
Yeah, so one thing that people get confused about is small modular reactors can be just smaller nuclear units. So we've already had this for 60 years in nuclear submarines and icebreakers. But when we talk about fourth generation, which are the safety inherent features and these novel technologies, China just built their first one and they have that online. Russia has a floating small modular reactor. So essentially what they did was they put a small modular reactor on a ship, and the ship can go to communities along the region that are supplied with power. So it's basically like a mobile unit to supply power that needs that. Here in Ontario, we're building our first demonstration unit, which will be built at Chalk River in 2026. And Ontario Power Generation is going to do the first one in Canada, and that will be fully operational by 2028. So in terms of Ontario and Canada, our first one will come online by 2028. In the States, Bill Gates partnered with Warren Buffett, and they're transitioning a coal station into a small modular reactor. That's called the Natrium reactor. That will come online in 2028 as well. But if we look at China just announced that they're going to dump $440 billion into nuclear, and they're going to build 104 new stations. Right now in the world for nuclear, we have 440. So you can see when they say they're going to build 100 and dump $440 billion, China and Russia are going to be one of the leaders. But we see Estonia, we're starting to get small modular reactors. Maybe it's Estonia. And we have other countries that are coming online as nuclear nations like Belarus. United Arab Emirates just came online. So again, it's expanding rapidly.
Wow, that's amazing. And thank you for a lot of this knowledge. I wish we could answer a couple more questions, but I think I'll have to cut this off so I can have a bit of closing comments. Obviously, Brad, if you're willing, if you don't mind, you can throw your email. I can put your email into the chat, or I'll send a note to all the participants today, so that they can reach out to you and answer some questions. I'll probably follow up with a couple of the pre-submitted ones with you, and maybe we can send the communications out. But most of all, thank you very much for presenting all this knowledge. I've definitely learned a whole bunch about nuclear reactors, how far they've come, these additional processes beyond splitting the atom. That's news to me. Like, it's really exciting from someone who's spent an entire career in oil and gas. And everyone else, thanks for coming to this event. I mean, that's pretty great for Milika to be joining us in Austria, and Lovepreet from India. That tells about the interest in this industry. We hope to have more of these again in the future. I'm going to throw a link into this for a survey into this chat to see if you can give me some feedback. We'd love to understand what people want to hear more, whether they enjoyed this, how we can do this better. And Matt, as a token of appreciation, we always try to actually give you the gift of coffee. So we'll be sending you a gift card for some coffee with us. Hopefully, if restrictions ease, you can maybe take out one of our participants for a coffee that's based in Toronto. Please sign up for anyone else if you want to join our Young Energy Professionals Network. We'll keep you informed of future events from our organization, as well as the Energy Council of Canada. And our next upcoming event is a mentorship event about how to communicate with influence from the Interpersonal Intelligence Institute, and it's facilitated and run by Gregor Jeffrey, who's a professional coach an executive coach in speaking and communications. So that's coming up in March. So keep tuned. Again, big round of applause, and thank you very much, Pat, for participating and having us for this great event. Thank you very much.
Yeah, thanks.
Take care, everyone.
And I left my email in the chat if people have other questions as well. Thanks so much, everyone.